So, good afternoon. This is my report for the chapter 4.7 relating to a uniform series or annuity to its present and future equivalent values for the completion for the INC grade for the engineering economics. So, let's start. So, what is annuity? So, annuity is a series of uniform or equal receipts or payments, each of amount A, occurring at the end of each period N, periods with interest at 1% per period. The notations involved here are P, which is the present equivalent value that occurs one interest period before the first period A, or which is the uniform low amount. For the F is the future equivalent value occurs at the same time as the last A and N periods after P. And A is the annual equivalent value occurs at the end of the period 1 through N inclusive. So we have this figure 4-6, which is the general cash flow diagram relating uniform series or the ordinary annuity to its present equivalent and future equivalent values. So there are four formulas relating to A to F and P. So the first formula is the ordinary annuity, which is the first cash flow being made is at the end of the first period finding F when given A. So this is the formula. So we know that F is equals to A, open bracket, open parenthesis 1 plus I, close bracket, raised to the N, which is the years, minus 1 over I, close bracket. So we can equate it, and if is equals to A, open parenthesis F over A, comma, so the I or the percent for the N, which is the year, where we can equate it as equal. So that is what we call the uniform series compound amount factor. So we have our second formula, which is defined as the first cash flow being made is at the end of the first person finding P when given A. So this is the formula. So equate it, and we have our uniform series percent worth factor. That is our second formula. This is our second formula. So we have our third formula defined as the first cash flow being made is at the end of the first period finding A with a given P, F. So F is given here and you have to find the A. So this is what formula can get. So this is the formula. If the given is F and you're finding for the A. So this is the formula, which is the sinking fund factor. So this is the fourth formula, which is defined as the first cash flow being made is at the end of the first period finding A with the given is P. So at this formula, our given is P and you are going to find the value of the A. So let's take up the formula. Let's see what the formula is. So here it is. So we can see that A is we're going to find it, and where P is given. So this is the formula. We know that these two formula is equal. So we have equated, and this is our capital recovery factor formula. So we have our problem, sample problem 4.17. So in 1803, Napoleon sold the Louisiana Territory to the United States for $0.04 per acre. So in 2004, the average value of an acre at this location is $10,000. What amount compounded percentage increase in value of an acre of land has been experienced? So let's take and see the formula. So this is the solution, and given which is the A, which is the annuity for the $10,000. So P, the past cost of the land, which is $0.04, and N for the years 2014 minus 1803, which is 211. So what is R? So we will be using the formula A is equals to, because we are finding for the R, so we are going to use this formula. A is equals to P time, open parenthesis, 1 plus R over 100 close parentheses raised to 211, which is the year. So input the value and do some little algebra and you come up with R is equal to 6.07%. The next problem is the problem 4.24, which states the Dominion Freight Company has invested $50,000 in a new sorting machine that is expected to produce a return of $7,500 per year for the next 10 years. At a 7% annual interest rate, is this investment worthwhile? So let's take and see if this is worthwhile for the investment. So we have our solution. So in PV or the dollars is equals to negative 50,000 plus 7,500 times PVIFA at 7% for 10 years. So do the math. Is equals to negative 50,000 plus 7,500 times 7.0236 and do the algebra. So NPV is equals to 2,677. So since NPV is positive here, we can see that the investment is worthwhile. Hindi ka nalugi. Tama yung pinasok nyo, sir. So the problem 4.27, which states a credit card company wants your business, and if you accept your offer and use their card, you will deposit 1% of your monetary transactions into a savings account that will earn a guaranteed 5% per year. If your annual transaction total an average of $20,000, how much will you have in the savings plan after 15 years? So this is our solution. So the amount of savings after 15 years is equals to $20,000 times the 1% times the FVIFA for the 5% for 15 years. So it's equals to $200, times 21.586 is equals to 4315.72. So thank you. That ends our discussion.